Dependency injection is a software design pattern where a class receives its dependencies from an external source instead of creating them itself. This approach, which achieves inversion of control, decouples classes from their dependencies, making code more modular, reusable, testable, and maintainable. Instead of a class building the objects it needs, those objects are injected into it, often through its constructor. What is dependency injection? Stack Overflow.
The dependency injection is a common pattern, and which it has a framework which can have containers. These containers manage the dependencies, and like your view model will receive the external dependency from the dependency container, like the framework provide external dependency to your component, and your component is called by the framework. So even your component is managed by the framework, like the DI container. So it achieved the IOC, inversion of control. The inversion of control is in inversion of the flow of control, which is like your customer code, your class created an external dependency internally. Instead of that, a container, a framework, which create your component when it needed and call it when the framework needed, and which is so inversion control, and this mechanism is the dependency injection. So let's see why we use dependency injection. Let's create a Android Jetpack Compose project. Close project, and so you open your Android Studio, create a new project, and phone and tablet, empty activity, and we call it dependency injection demo. Create. And okay, so this is the application. Let's click and run. And say hello world is the default application. So let's see why use dependency injection. So we can say let's go create the package, some refactor. Let's say we got a new package, pages, and we got this greeting into a page. Let's say new Kotlin class greeting, and we say okay. I can remove this. So now that you have a page of greeting, and like very common is you have a package of view models, and view models you have new Kotlin class like greeting view model, and this is of type of view model. Okay, now you have your page. Greeting have a view model, and so let's say your view model, calls to an external service. Let's say you have service, new package, services, and this service is called Kotlin class print service, and your print service, which you have a function of print, and print line. You're saying actually this not print, is a return a string. Say return the external service will print out the and like your view model, you will say inside your view model you will create a print service. You create your service inside your view model, and which equal to greeting service print service. Equal to print service, and for example, in this way, now go to your page. Your page has a view model, which is type of greeting view model, and which equal to view model. So to get your view model, you need go to get this dependency. It's the view model function for the compose. So you go to Gradle build, and let's say compose view model, and sync. It will import the dependency. And you go to here, you can say your text, which equal to, instead of names, and instead of names, you don't need the name anymore, and you go to main, you don't call the greeting with the name, and the text will be the print service has the following, and then you can say view models print service dot print. Okay, so now run your application. Oh, you don't need this preview. Now run. So it says the print service has following the service will print blah blah blah. So this is coming from the print service, and the print service this is no the way you create your external service internally inside your customer class, your customer code. So you instantiate the print service class over here. So you created the service, the flow of control, which is inside of your customer class. And why this is so why you need inversion of control IOC? It's like for the view model, you have, let's say, another view model, like say another page is home page, home view model, and your home view model has exactly the same code, so you repeat the same. It needed the print service, so you repeat this code inside of your home view, and you have another view model, like you have another page. You can write another page, and the page you can say profile view model, and you create your print service in your profile view model too. So you are keep creating the external service inside of your class, and the flow of control is internally. And what happened is your print service now you need a parameter like say dependency type. I'll just say string, but it could be dependency or any objects, and you can have dependency to of any object. And if you change your service over here, and you will get error because you need to change the code, right? You need to change the code. It's like no, you need to pass the dependency into all these three view models if you make changes. So this from the reusability and the maintainability, like it's hard to maintain, right? If you change your code inside of one of your class, and you need to make the modification everywhere. So basically, you know that the solid principle, it's like the code should have single responsibility principle, and it should open close principle, this code substitution principle, interface segregation principle, and dependency inversion principle. So this you need change that the print service everywhere. You say types 1 which equal to types equal to allow, and type 1 which is to Oh, okay. Oh no, actually, what we mean is your print service need the constructor need a dependency. So this, inside of this, you can see. After that, you need to go everywhere. Say the print service will need a type equal to something type 1, type array, and type 2 equal to type 2. And you need to change it over here too, right? Because you are repeating your code. Say this type need by the other view model and a profile. Same thing. So if your service change, you need the code to be changed everywhere. That's your flow. Inversion flow control is solve this problem. Is it's the flow of the control is inverted. Instead of you create your external dependency inside of your customer class or customer code or customer class, and so your class. So actually, your class is called by the framework, and the framework can provide you the dependencies for your customer code or class. So for how to achieve the dependency injection is then you let's say you remove your print service internally inside of your view model to get dependency injection. So it's normally achieved by the constructor injection. So you can say you need a print service. For this, you can say well PS which is type of print service. So in this way, in your constructor, you inject your print service, your external service, and but this is not all, because you didn't create the service. If you create you need to pass the creation of service to the framework, not you create it by yourself. That's where the dependency injection framework of Dagger can do the work. So let's say dependency injection with Hilt. This is the framework, and what we are going to do is let's follow this, because let's copy. You need a KSP, because you can see you need a KSP, Kotlin's symbol processing tool. So let's say you go to this page, get the KSP to work. What you need is this. Let's quickly get Help Dagger work. So go to your project and get this KSP tool, apply false, and then enable KSP in module level, build.graduate.kts. So go to your module level, go to your plugins. So now you need sync, get this KSP tool. Then you can go back to the Hilt and add the Hilt and Gradle plugin to your project's root, build a Gradle file. So you copy this field, go to your project and paste it over here, field sync now, and then go to your apps build a graduate. Apps build graduate and got this, and go to dependency. Now because you use KSP, so you need the first step, and now you can say build over here and sync now. Okay, build successfully, good. So now say you have your print service, and so inside your greeting, your greeting view model class, greeting view model, and you specify this is a dependency injection is using that constructor. So you say you need a print service, which is type of print service. And if you say your greeting view model, this is PS. So now you can see from the main activity, you got the greeting page. The greeting page, you have the injected dependency of greeting view model, and your greeting view model injected the print service or through the constructor injection. So you get the printing service over here, and view model, let's say view just called the view models printing service print, and we have got the dependency injection framework of Hill Dagger setup. Let's see. Hill Dagger setup is, say, you got the plugins. We instead of Capital, we're using KSP, and you got the dependency and the symbol, and to square up the hilt dagger. So first you need it needs some setup. Let's set it up. You need a markup. You need to create a new class called DI app, and this DI app you need markup with you need an app, and this app will be here, Android app, and this class which will be type of application member class application. So you need to use the annotation of Hilt Android app, and which trigger Hilt code generation, and create the application level dependency container. Create a dependency container over here, and this is a step-by-step setup. So you need first create an application, and this you need to go to your manifest and say your application has a name, the name which is dear app. That's your application name. And you need a module definition. Let's say we can create a new package or DI, and inside this DI you create a new Kotlin class, app module, and this app module, then you can say we annotation like it's a module of dagger, and let's say install in singleton component class, and add install in import okay. So that's your app module, and this is object object and we want to provide our print service, even it's a markup service, but let's say it could be any service, right? And then we can say provides it's from dagger, and add singleton. So this print service can be used across all these view models or other classes. It's a singleton, and the function, let's say provide print service a function, and this will return print service. So this because if you use the annotation of provides and specify the scope of singleton, and your provide print service function, which print type, return type is print type, is the print service of your customer service, and you return, what you return is print. So this is your print service, right? Has two types. So generally you will say print service, print return print service, and type equal to a type, and 2 equal to b, a dependency and b dependency. And so here then you can see the framework provide external service to your customer class of all your view models. So instead of, so you do not need to create your external service. You just specify the type, and the framework will provide you the external service to you. So, and because your framework will always create even your view model when the lifecycle needed, and destroy it and manage the lifecycle by the framework. So instead of your code, the flow of control is inside of your customer code, and the framework provides the control of flow. And let's make the module. It has the okay. So now you need to say, let's say you need mark your view model with health view model. So instead of, you can see its health view model is managed by the health framework, health diagram framework. So when the application need your view model, it will create for you. So let's say the page. Go to your page, greeting, and your view model, which is greeting view model and this view model, and go to your greeting view model. This, because you need the dependency injection, then you need inject constructor. You need a injection. This inject is inject constructor of dependency injection. And let's say right now all of your classes in management by the dependency injection framework of health diagram. And let's run application. And one more thing, you will get error because you need a specified Android start point. This is Android intro point. And your main activity is Android intro point. You specify by using the @intro point. And you use health to manage the dependencies, so this will be health view model. Okay, so now the health diagram, the framework is set up finished. We can run the application. And you can see it print out the service will print out this, and you can see your customer code, like the view model of greeting view model, is managed by the framework. The framework calls creation of your view model, and its dependency, your view model's dependency, is injected by constructor, like this is print service, and it provides the creation of print service by the framework of health diagram now. So it's a health view model, and your service over here is provided by the dependency injection framework. The module over here is provide print service, which return type, which is the print service type, and all the service, the external dependency is management by the framework, and when it needed, it called to create the required service, required component of your view model or your service, any dependency managed by the framework now. And we can say this scope, it has singleton, activity, or view model scope, And the benefits using dependency injection, you can see it's more testability, so using easy markup dependency in unit test. Reusability, you can see your any change you want to make, it's only by inside your customer code, like your print service. Any modification you can make it here, and the calling class or customer code, like you don't need to change the calling code anymore. So more reusability. Decoupling, the class is instead of tight coupled like your old code, which is say print service is like a print service equal to print service, and the dependencies over here. Instead of tight coupled, it's loose coupled. So it's decoupled. Class only know how to use the dependencies, and the lifecycle automatic lifecycle management by the framework of Dagger. The common work is like network clients like retrofit or OK HTTP, and local database instance like Room, repository pattern implementation, analytic and logging service, shared preference, and data store and view model with dependencies. So for the network clients like retrofit or Room, you can go to my another video over here, and there's the code. You can access it. You can see the code. It uses the dependency injection. The DI provide retrofits and Room database. So the sample code, you can go to my video and see the sample code over here. So it has repositories, network use retrofit, Room database, and that's the GitHub for that sample code. Okay, that's the dependency injection.